By now, we've improved our app to be easier to navigate and ordered reviews by people who tend to rate things the way the user does. But there's more that we can do to bubble up and extract businesses that we think the user will like as a form of recommendation. Yelp has a friendship network, and we know that influential reviewers tend to be predictive of which other businesses or which businesses will be reviewed by other users. Now, we're going to use this as a stand-in for predicting becoming a reviewer and showing people information that they will likely find more important or more significant based on their network. Now, our challenge in this section is to show business results based on the positive review of influential users in the Yelp network. But because Yelp is such a highly connected data set, we don't want to look at all possible influential reviewers. We only want to take into account those that are closer to our user in the network. The personalized PageRank algorithm is a variation of PageRank that is very handy for recommendations. But before we dive into that, let's start with PageRank itself, which is probably the best known centrality algorithm. It's been used in a wide range of analysis from either indirect or overall influence in networks, from food webs to connections in the brain, of course, ranking pages, biological processes, and even in criminal networks. So PageRank has quite the history. And what it measures is the directional influence or the transitive influence of nodes, considering the influence of your neighbors and their neighbors and their neighbors. So an example of this type of influence is let's say in a military situation, the difference between having the ear of a general that considers you credible will likely make you more powerful, have more influence than being simply very popular with your fellow foot soldiers. Now, PageRank measures this importance in comparison to other nodes using this iterative process to update its ranks. So things are ranked between whatever you're measuring. If we take a quick look at the process that PageRank goes through, it starts by assigning values to the nodes by the 1 divided by the total number of nodes. In this case, we can see we've got 3 nodes. Each of them get a value of 0.33. It then initiates a link value that is the node value divided by the number of that node's outlinks. So if you have a 0.33 value and you've got 2 outlinks, as we can see the top node has, each one would get a 0.17 value. And that's the initiation pass. It then goes through the first pass and makes an update at first to update the node value as the sum of the prior in-link values. So in this case, we can see in the lower left corner, let's see here we go, that node now gets an update of 0.5 because it has 2 in-links. One in-link has a value of 0.17 and another link has a value of 0.33. You add those 2 together, you get a 0.5. This node that previously on the right that had a 0.33 value only has one in-link with a 0.17 value. It takes on that value. It then goes through and updates the link values previous to the same way we had seen in the first pass, looking at node value divided by the number of outlinks. And we have 2 updates in this case. This process continues over and over again until one of 2 things happen. Either it converges on a solution where the values are no longer updating, or you reach an iteration maximum. One of those two things will happen. Now, we can see in the formula for PageRank, if we're looking at the node U in this case, and we're trying to rank that, we first need to look at the nodes that are linking to U because we're looking at that transitive value. And so we look at those PageRank of those nodes and then divide it by the out degree of those nodes, as we saw in the previous section. So here, C for T1 is the out degree of the node T1, and CTN is just shows the continuation for all the nodes going to the end point. Now, an interesting thing about PageRank is a dampening factor that's added, and here we shown by D, right there. Now, the dampening factor is added to help keep PageRank from getting dragged down into loops and tangents. You can imagine a network following a path, and you might come to a dead end, or you might come to a loop where everything is connected to each other in kind of a circular loop, and it might drag and rate that PageRank higher because it would be caught in the loop. Now, the dampening factor is a probability that the next step of the algorithm will follow a direct path, following from one node to another node to another node. And it's basically the opposite of a random skip to another node. It sets the value by which either you follow links from one to the other, nodes from one to the other, or you hop to a random node. For example, a standard dampening factor is 0.85, and that means that each calculation there's actually a 15% chance that the algorithm will look at a random node not directly connected to it at that particular moment. 1 minus D is simply the probability that a node will be reached directly without following any relationship. Now, the dampening factor is kind of interesting because this is how we're able to use and able to create the personalized PageRank, how it becomes personalized, really. Instead of doing a random skip to a completely random node when that dampening factor comes into play. So when our dampening factor comes into play, instead of going totally random, what the personalized PageRank does is it sets a source nodes area. So you can establish the area around a particular node or a community as the skip back area. So when you go to skip that random 0.15% of the time, you're going to skip back closer to or around your originating node. And this gives us a look at influence of the graph that's never too far away from our starting point. And of course, we can tailor our results by changing the dampening factor, changing the number of source nodes, how widely we include, what kind of community that looks like. And you can see why personalized PageRank is particularly useful for looking at influential elements surrounding a particular area. Now, this is different than a similarity algorithm that measures how common things are, and it's different than a community algorithm or community detection algorithm that's just looking for what are the groups. We're looking for, within a particular area, what are the most influential, highly ranked nodes. By the end of the section, we'll have updated the search results to highlight the Yelp businesses with good ratings from other users with a high personalized PageRank for that user's searching. You should be able to explain why personalized PageRank is used for recommendations and how it's different than the standard PageRank itself. You may also want to familiarize yourself with changing some parameters and source nodes and how that might change your results.